Let's solve some problems. Okay, let's say we have an vector x1 is equal to 1, 2, 3 and x2 is equal to 2 minus 2, 0. What we have to figure out is whether it is linearly independent. Okay, so let's convert this into matrix form. A is equal to 1, 2, 3, 2 minus 2, 0. Okay, now let's we use the concept of minus of the matrix. Now the minors would be 1, 2, 2 minus 2, 1, 2, 3, 0 and then 2, 3 minus 2, 0. Okay, now let's figure out or evaluate this. So minus 2 minus 4, which is minus 6. We don't have to proceed further. Yes, because this is not equal to 0. So which means that the rank is 2. Now since the rank of A is equal to the number of vectors implies that the vectors are linearly independent. Yes. So here we were lucky that the first minor itself that we identified is not equal to 0. Sometimes you might have to go through many more. Let's do the second one. Let's say x1 is equal to 1, 2, minus 3, 4. x2 is equal to 3, minus 1, 2 and 1. And x3 is equal to 1, minus 5, 8, minus 7. Let's write it in the matrix form. 1, 2, minus 3, 4, 3, minus 1, 2, 1, 1, minus 5, 8, minus 7. Let's reduce it. Now to reduce it, if we can get two of these rows equal to each other, that would be great. So let's do one thing. Let's replace R2 by R2 minus R1. So what I'm doing is not R1, 2R1. Okay, so now what happens? 1, 2, minus 3, 4. And here 3 minus 2 gives me 1. Minus 1 minus 4 gives me minus 5. 2 minus minus plus 2 plus 2 plus 6, 8. 1 minus 8 minus 7. So you notice that our second and third rows have become equal, right? So which means we can get rid of the third row by subtracting it from the second row. So that means rank is equal to 2. And since rank is less than the number of vectors, therefore linearly dependent. Okay, so we can also say that there are two vectors out of 3 which are linearly independent. First and second or first and third are linearly independent depending on which one we convert to 0. Okay, so now what we need to do is write it in the form of a linear combination. So write one vector in linear combination of the other vectors. Okay, so how do we do that? Remember, to arrive at this, we did R2 minus 2R1. So R2 minus 2R1. By doing this, we made sure that the second row and the third row becomes equal. So we can say x3 would be equal to x2 minus x2x1 minus 2x1 plus x2 is equal to x3. So that's it. Okay, let's do the next problem. Now x1 is equal to 1 0 0, x2 is 0 1 0, and x3 is 0 0 1. Again, we have to figure out whether they are independent or dependent. So we can write this in the matrix form: 1 0 0 0 1 0 0 0 1. Okay, now it is already in the reduced form, so that means rank is equal to 3, and rank is equal to the number of vectors. So therefore x1, x2 and x3 are linearly independent. Okay, fourth one, let's say x1 is equal to 1 0 minus 1, x2 is 2 1 3, and x3 is equal to 1 0 1. We have to figure out whether they are independent or dependent. So again, let's write it in the matrix form: 1 0 minus 1, 2 1 3, 1 0 1. And now let's reduce it. So R3 minus R1. So the equivalent would be 1 0 minus 1, 2 1 3 0 0 minus 2, 1 minus 1 minus 2, no, 1 plus 2, 1 minus 1, 0 minus 0, 1 minus 1, that is okay. So now let's take care of this. So R2 replaced by R2 minus 2R1. So the equivalent matrix would be 1 0 minus 1. This would become 2 minus 2, 0, 1 minus 0, 1, and then 3 minus minus, so plus 2. 3 plus 2 would become 5, 0 0 2. So here rank is equal to 3, and since rank is equal to the number of vectors x1, x2, x3 are linearly independent. Okay, so that's it. Bye.